This is February, March 2023, 9709, City 2, Paper 3, Pure Mathematics 3. Question number 1. It is given that x is equals to natural log of 2y minus 3 minus natural log of y plus 4. Express y in terms of x. Now, for the solution, x is equals to natural log of 2y minus 3 minus natural log of y plus 4. So here we need to recall the properties of the logarithms or the laws for the log. So here, if it is log of a over b, we write log of a minus log of b. Keep in mind that log of a is actually log a to the base e. If the base is e, then it is called the natural log or ln of a. So I can apply this property here on the right hand side. Natural log of 2y minus 3 over y plus 4. The same, like if natural log of a over b is natural log of a minus natural log of b, and if there is natural log of a minus natural log of b, we can always write it as log of a over b. Next, you can also write it as log 2y minus 3 over, changing the sides, equals to x. Here, recall the definition of the log. If there is log of a is equals to say b, log of a equals to b, natural log of a equals to b. Natural log of a is actually natural log of a means log of a base e is equals to b, and this by definition is e raised to the power b. So you can apply this definition of the log here. So you can write it as 2y minus 3 over y plus 4 is equals to e raised to the power x. As we want to write y in terms of x, so cross multiply first. Open the brackets on the right hand side. Multiply e power x for e to power x. Then shifting all the terms in y on the left hand side, minus e to power x y is equals to 3 plus 4 e raised to the power x. And next, y is common. Inside is 2 minus e to power x is equals to 3 plus 4 e to power x. And finally, y is equals to 3 plus 4 e to power x over 2 minus e to power x. So y in terms of x is here. So we have expressed y in terms of x. So, and for this solution, we used the properties here. The natural log of a minus natural log of b is log of a over b. Also, this important definition, natural log means log of a to the base e, and by definition, it is a equals to e to power b. So in this way, you can express y in terms of x. Question number 2. On an Argand diagram, shade the region whose points represent complex numbers z, satisfying the inequalities minus 1 over 3 pi less than or equals to argument of z minus 1 minus 2 iota less than or equals to pi over 3 and real part of z equals to 3. So before starting this question, let us check what is, recall what is argument actually, argument of z minus. So I can write argument of, I can write argument of z minus 1 minus 2 iota is equals to pi over 3. This is actually argument of z minus 1 plus 2 iota is equals to pi over 3. And yes, this is half line. This is the half line. And half line, what is the end point of the half line? 1 plus 2 iota is the end point, or for the convenience, you can write 1 comma 2 is the end point, and pi over 3 is the argument. Second is argument of z minus 1 plus 2 iota is equals to minus pi over 3. Again, this is half line. This is half line, and endpoint is here, or you can write 1 comma 2. Also, the third was real part of z is less than or equals to 3. You can write real part of z is equals to 3. Keep in mind that real is x is equals to 3. So we'll be drawing these three locus on the same axis. So the end point is 1 plus 2 iota, 1, 2 is the end point, and the angle with the real axis is pi over 3. And so here what I can do, I can draw a sketch. 1 comma 2 is approximately here. I can draw a line in this direction. This is with endpoint 1 plus 2 iota, and the angle with the real axis as pi over 3. The second is minus, means here exactly this other locus, minus pi by 3. The angle is pi by 3. Magnitude of the angle is pi by 3, so you can write pi over 3 is but the argument is minus pi by 3. Also, the line x is equal to 3. So this line x equals to 3 can be, so first we need to know whether this line is here or here. So in order to get the exact position for this, to draw the exact this line x equals to 3, we need to know this point where this half line is intersecting the real axis. And for this, you can recall basic algebra, basic concepts of coordinate geometry. This figure is there, and in this figure, the figure on the right side, this figure is for the working. The points are 1 comma 2, and this point, as it's on the real axis, it can be a comma 0. This point is a comma 0. If this point is a comma 0, also if this angle is pi by 3, by using the concepts of parallel lines, the properties of the parallel lines, this is pi minus pi by 3, which is 2 pi by 3. So this angle is 2 pi over 3. So gradient formula from coordinate geometry, if the line makes an angle 2 pi by 3 on the right side with the horizontal axis, the gradient is tan of 2 pi over 3. So the gradient for this line is minus root 3. Also, the 2 points are given, 1, 2, and a0. You can find the gradient by using the formula y2 minus y1 over x2 minus x1, and that value, that fraction can be equated to minus root 3. So in this way, you can get the approximate position for the position for the point where this half line is intersecting the x-axis. So 0 minus 2 over a minus 1 is the gradient, and just equate this to minus root 3. So calculation will give you the answer minus 2 is equals to minus root 3 and a minus 1. So when you simplify, it is 2.15. You can verify 2.15. So this is 2.15 comma 0. So obviously the line x equals to 3 is after, because this value is 2.15, it is here approximately. So draw the vertical line passing through x equals to 3, and this vertical line is now here. So this is the line, vertical line passing through the points. This is the third locus. So after drawing the three loci, so the question is to shade. So you'll have to shade the region. So greater than minus pi by 3 means greater than this line, less than pi by 3, and here. So finally you can, for 3 marks, you can shade the region on the Argand time. So this is the shading for part A. So shading for part A is here. Second part is calculate the least value of argument of C for the points in the region from A. You will answer to 3 decimal places. So in this region, you'll have to identify a point whose argument is least. Argument is least. Argument of Z is least. So Z is the region, is the point in the region. So if you there are many positions here. If we take this point, so yes, we have the argument of Z. This is the argument of Z. This is the argument of Z. This can be, but this is the point in the region whose argument is least. Whose argument is, so not this one, not this one, not this, but here. So this is the region. This is the point here. This point, which is in the shaded region, and for this point, the argument is least, means this value is least. So we have this green triangle. Actually, this angle is theta, and this theta is question mark, and obviously this is clockwise answer. Our argument would be negative. So find the magnitude, then we'll put the negative sign with that. So this theta is actually question mark. And for the theta, we have a right angle triangle. So for this right angle triangle, the length from this end to this end is 3. And if this side is given, you can easily find the angle, but this side is not there, means this side. So without knowing this side, which is opposite, you can't measure the angle. And for this part, what you can do, you can recall basic trigonometry. We have a triangle, this triangle, which I have, this angle is pi over 3. The length from this end to this end. So from 1 to 3, this is 2, and this is the question mark. This is the question. Say if this is x, so x over 2 is equals to tan of pi over 3. So x is equals to 2 tan pi over 3. 2 tan pi over 3, and tan pi over 3 is root of 3. So we have this value from this end to this position. So from this position, the measurement is 2 root 3. Also, this length is 2. So 2 root 3 minus 2 is here. 2 root, so this length is bigger, which is 2 root 3 minus 2. So 2 root 3 minus 2 is this length. And using these two, you can find here this theta means tan of theta. Tan of theta is 2 root 3 minus 2 over 3. Let us use calculator for this. 2 root 3 minus 2 divided by 3. and inverse tan is 0, theta is 0, answer is required to 3 decimal place, 0.454. So this is 0.454. So this measurement is 0. But when we talk about the argument, this is clockwise. So argument of z, so z is basically this point, and origin is here. So therefore, finally, argument of z means this measurement clockwise is equal to this measurement is the argument. This is the argument. So clockwise magnitude is 0.454. So minus 0.454 is the argument, is the least value of the argument of z. Question number 3. The polynomial 2x4 plus ax cube plus bx minus 1, where a and b are constants, is denoted by px. When px is divided by x square minus x plus 1, the remainder is. So here, this part is the dividend, this part is the divisor, and here is the remainder. Recall the basic identity that divisor multiplied by quotient plus remainder. 2x4 ax cube bx minus 1 divisor x square minus x plus 1 quotient, and the remainder 3x plus 2. So as the first bracket is quadratic, and on the left hand side we have x power 4, the degree of the dividend. So which type of bracket should be here? The second, the quotient, it must be a quadratic, because quadratic multiplied by quadratic can be x power 4. So here I can write the quadratic as b, a and b are already in the question. So you can introduce the quadratic as cx square plus dx plus e. So question is to find the value of a and the value of b. So on the right hand side, I can multiply the brackets. So for the multiplication, you can do it directly, or you can show all the steps there. X square is multiplied by cx square plus dx plus e. Then minus x is to be multiplied by cx square plus dx plus e. And plus 1 is multiplied by cx square plus dx plus e, and 3x plus 2, which was the remainder. Now here, carefully open the brackets. It is cx power 4 plus dx power 3 ex square, cx power 3 dx power 2 ex, cx power 2 dx e 3x plus 2. Left hand side was 2x power 4 plus ax cube plus bx minus 1. Now comparing the coefficients. So compare x power 4 on both sides. 2 is equal to c, the only term in x here. Compare x power 3 on both sides. It is a is equal to. So if you compare x cube, we have this term in x cube. There are two terms in x cube on the right hand side. So d minus c. D minus c. As we have the value of c here, you can use the value of c. So a is equals to d minus 2, and you can mark this as number 2. Next is compare x square on both sides. There is no term in x square on the left hand side, and the right hand side, the terms in x square are this term, second term, and there are three terms on the right hand side. So 0 is equal to e, just compare the coefficients, e minus d plus c. As the value of c is already there in the first, so it is e minus d plus 2. Number 3. Comparing x on both sides, b is equal to. So the term in x are this term, and these are the terms in x on the left hand side. So equating the coefficients, so b is equals to minus e, b is equals to minus e plus d plus 3, and say this is number 4. And finally comparing the constants on both sides. So the constant is minus 1 on the left hand side and the right hand side, the two terms, constant terms, these are the two terms, e plus 2, and so we have the value of e is equals to minus 3. So e is equals to minus 3, and this is number 5. So question was to find a and b. So c is there, and we have used the value of c in 2 and 3. So finally we have e. This e can be used in 3 for the value of d. So you're using 5 in, using equation 5 result in 5 in 3. So 0 is equals to e minus d plus 2. 0 is equals to minus 3 minus d plus 2. 0 is equals to minus 1 minus d. So the value of d is equals to minus 1. Value of d is equal to minus 1. So this value of d can be used in number 2. We put this value in number 2. D is equals to minus 1. So D was equal to minus 1. Put this value in number 2. So 2 is A is equals to D minus 2. So A is equals to minus 1 minus 2. So the value of A in this way is minus 3, which is the answer. A is equals to minus 3, and this value can be used. So for the B, you can use 4. So equation 4 implies, so in 4 we have B is equals to minus E plus D plus 3. B is equals to minus E. E is minus 3 plus D. D is minus 1 plus 3. So B is equals to 3 minus 1 plus 3. So 3 to 6, and so value of B is coming as 5.